Okay, so we have a ball. We can have the ball be influenced by different forces. We've learned how to draw an arrow and use that arrow to represent different quantities in a program. Another helpful thing to do is to be able to plot output from the program as the program runs. This is not super intuitive, so I'm going to walk you all through this. Let's see, let's go right above our code for Bill, and I'll start a little section of code where we initialize the plots. I'm going to have two components. There'll be a plotx component. The function is gdots. I don't know what the g is for specifically, but the dots is about a scatter plot. Let's have our x plot be a color, we'll make it red. That'll match the color that we have in Logger Pro for x, which y'all are used to. And then the same thing for y. Y g dots, color equals color. Let's make this one blue. Okay, that sets up the plot x and plot y, and we're ready to write to it inside our loop. We will need another section to do that down here in the loop. I'm going to go right before updating the time, and I'm going to start a new section, and I'll call it update plots. All right, I'm going to start working that plot x variable. So the idea is every time the loop runs, we want to put a position on x and y on a particular plot, representing whatever we would like to represent. So on plot x plot, I'm going to put a dot at a position which is equal to the x and y coordinates, horizontal and vertical coordinates of whatever I want to plot. I'm going to have this plot be as a function of time. I already have time identified as t, so that'll be the horizontal coordinate of that dot. And then I'm going to plot the x and y positions of the ball. So here, it's ball 1, that's my object. POS is its position, but that's a vector. So I call the x coordinate of ball 1's position, and I'm going to plot that on my plot x. So that there will place a dot on plot x at a position tx. Okay, same thing for y. So plot y, I'm going to put a dot at a position of time ball1.pos.y, so the y coordinate, and that will place a dot on plot y at a position ty. Make these look like the coordinates that they are. Okay. If I go up here and run the program, we'll see the same output we've seen at the top, but underneath we get these plots as the ball moves. So the red is the x coordinate, that is position as a function of time. In x, there are no forces acting on the ball, no horizontal forces, and we see that the object in motion stays in motion and moves at a steady rate, constant velocity starting at -5. That is Newton's first law at play. In the y dimension, the blue, we start at +5, but there's a downward acceleration, so the ball slows down until it reaches a peak, and then it begins to speed up in the negative direction until it passes back down through the past the origin. You can plot whatever you would like to plot, any of the quantitative output of the program that you can dream up. So for example, if I didn't care about the position of the ball, I could plot the ball's acceleration or the ball's velocity. Now note, acceleration and velocity in this code are both vectors, the way that they're defined. So if I wanted to plot, say, the acceleration of the ball, I'd have to choose whether I want to plot the x acceleration or y acceleration, or perhaps a magnitude. Here, I think I'll try ax, so the x acceleration, and down here we'll do ay, the y acceleration of the ball. Oh, I just zoomed out. That was by mistake. Let's go down to the plot. Here we are. X acceleration is 0 meters per second squared because there are no forces in x. And the y acceleration is right down here. Look at that. Right at -9.8 meters per second squared and constant as time goes on. Other fun things you could do, of course, are to plot the velocity in x and y, comma there. And we should watch the ball traveling at a constant x velocity in red, 10 meters per second, and then a diminishing y velocity in blue, diminishing at a constant rate because of the constant acceleration of the ball. Plotting can be a really powerful tool for outputting quantitative values from your code as a function of time as the code runs. So not just a final output, but continuously as the code goes. So if you ever need to get a quantity to read something quantitative out of your code, it can be a really convenient way to do that.